What if your AI agent could instantly connect to any tool ecosystem, file systems, GitHub, databases, Slack, without writing a single line of integration code? That's the promise of the Model Context Protocol, or MCP. It's an open standard for exposing tools to large language models, and Crystal AI has a built-in MCP client ready to go. Here's how MCP works at a high level. Your Crystal agent talks to a built-in MCP client. That client connects to one or more MCP servers. Each server exposes a set of tools. The file system server lets your agent read and write files. The GitHub server lets it manage issues and pull requests. A database server can run SQL queries. And because MCP is an open standard, there are hundreds of community-built servers you can plug in. Crystal handles the JSON RPC communication, tool discovery, and result routing automatically. Let's start with the stdio transport. This is the simplest way to connect to an MCP server. Crystal spawns a child process and communicates over standard input and output. In your agent's YAML config, you add an MCP servers block. Set the transport to stdio, give it a name like file system, and specify the command and arguments to launch the server. Here we're using npx to run the official Model Context Protocol file system server, pointing it at a documents directory. That's it. 3 lines of config, and your agent can now read, write, and list files. For remote MCP servers, Crystal supports the SSE transport. That's server-sent events over HTTP. Instead of a command, you provide a URL pointing to the server's SSE endpoint. You can add authentication headers, and Crystal supports environment variable interpolation using $curly brace syntax. This keeps your secrets in your environment where they belong, never hard-coded in config files. The env block passes variables to both headers and the server process. So whether your MCP server is local or remote, Crystal connects the same way. When your agent starts up, here's what happens behind the scenes. Crystal connects to each MCP server, spawning a process for stdio or opening an HTTP connection for SSE. It performs a JSON RPC handshake to initialize the session. Then it sends a tools list request to discover all available tools. Finally, it registers each tool with a prefixed name, MCP_server_name_tool name. So the file system server's read file tool becomes MCP-filesystem read file. This naming convention prevents collisions when multiple servers expose tools with the same name. The LLM sees these as regular function calls. No special handling required. Now here's where it gets powerful. You can configure multiple MCP servers on a single agent. In this Dev Assistant example, we have both a file system server running locally via stdio and a GitHub server connected remotely via SSE. Crystal discovers tools from both servers and makes them all available to the agent. The result? Your agent can read a source file from disk, analyze it, and then create a GitHub issue about a bug it found, all in a single conversation. Each server's tools are cleanly namespaced, so there's never any confusion about which server handles which tool call. Let's recap what we covered. MCP is an open standard for exposing tools to LLMs, and Crystal has a built-in client that handles the entire protocol. The stdio transport spawns a local subprocess, while SSE connects to remote HTTP servers. Tools are automatically discovered and prefixed with the server name, and you can mix multiple servers in a single agent, all configured in YAML. In the next video, we'll take these MCP-powered agents and deploy them as production APIs using the Crystal Server SDK and Express. See you there.